Hello and welcome to, we'll do this as our next vlog, but tour of the version 2.0 of the MotorDoc EMPOWER, which includes the ability to do DFIG wind turbines. Now in version 1.5 and 1.1F, we had included it to some extent, but we've included some additional features in order to make it more comprehensive. So in any case, this is the main screen. This black screen in the background, I've opened it up to full screen. This is kept live so you can see the software operate. That is included with when you have the software on your own, so you can see that things aren't hanging up. It is not an extremely fast processing, but that is deliberate because we're making sure that we identify the correct speeds and everything else. In this one, it's going to be a tour, so we're going to handle it as a data collection on a random machine, and as well as showing the ability to do a wind turbine. The data is actually going to be a single phase set of data from the laptop load. So I'm not going to have a motor running in the background, so we can keep it kind of clear, no distraction. So in any case, when I take a look at the screen, you can see the buttons, you see the bearing data, and then data collection. This is one of the new features that is mostly available. There's some additional things we're going to do as we move into the phase of continuous monitoring for this technology. Opening an existing analysis for doing reporting about will tell you basically that this is, let me grab that, version 2. It's actually, 2.0B, and the name, our contact information, and then just some stuff saying, use at your own risk. No technology is 100%, basically. In any case, the analysis screen in which all of this will populate as we go forward with the automated analysis, plus there's a new feature that's available on here. Estimated watts losses, this will populate a screen as well that will include navigation and everything in watts and kilowatts. The additional data, which is basically going to take for the machine only, not for the driven equipment, just for the machine, the losses associated with each component. Will include other components later on. Right now, this is sufficient for what we're doing. The motor nameplate information, and you can see what we had showed before, the DFIG wind turbine. There's a lot of extras that are going on behind the scene. The coupling and driven. So I've left this as pump or fan, or the team has, I should say, but we've left this as pump or fan. But this is also going to be, for wind turbine, this is going to be the number of blades, which would be 3 on a standard wind turbine, and then the main bearings. So we'll cover that in the wind only session that will be for users only. And then up here, all the different analysis selections, you can select more than one. The harmonics one in particular also includes supra harmonics, or harmonics over 50 orders, and interharmonics out to 22 kilohertz. Settings includes a setting, so the device I'm going to use, this is the sensitivity. That is a little sticker that we put on the side of it. This is going to be for continuous monitoring later, so you don't have to select anything here. The millivolt per amp is very important. You need to select the correct one for the device, and we're going to go through all of that. This would be for data related to energy and emissions for the auto analysis. And what's kind of cool about this section, including setting the alarm limits, well, there's two things. First is, this is the default alarm limit. The software then makes adjustments based upon where the noise floor is, so that you maintain a constant, it reduces false positives and false negatives, basically. So let's go ahead, and we're going to set up a pretend motor from scratch, showing some of the new features that exist. So for this, we're going to go ahead and we're going to create a pretend motor. We're going to call test motor 2.0. We're going to call it 2-0. Manufacturer laptop for fun. Kilowatts, because I want to do the energy analysis. Horsepower does not presently. We're going to have that updated later. You'll notice it's kind of, some of these are kind of off, where it's like, well, why didn't they do it now? Well, it's because of where it is. It's part of a bigger update that's going on for new features that are planned down the road. So we don't want to do bits and pieces. We're going to release those updates so that you'll see everything at once. So in any case, so kilowatt, so that would be 0.746 versus 1 horsepower. Now I can put in decimal numbers in here. 1785 RPM, 60 hertz. We're going to call it 230 volts, 2.5 amps of current, and nameplate efficiency, etc. here. Operating hours, we're going to say 8,760. Number's going to be very low because it's a very small machine, and 10 cents per kilowatt hour. Rotor bars, let's say there are 28 and 36 stator slots. For owners of the EMPOWER system, we do have a spreadsheet with some motors in it, about 850 of them, 8,500 of them, not 850, that we make available. Eventually, we may build that into a database. Now, we did build the bearing database in. So how you use the bearing database is this. So you open up the bearing data, which pops up as a system here. The reason for the large gray area here is for that eventual rotor bar and stator slots. We're going to be mixing in also information for wind. So all of that is going to end up in this section. But in any case, let's go ahead and we're going to select an NTN bearing. I'm sorry, an SK. Let's do an NTN this time. So we'll do an NTN bearing. And then what we want to do is highlight the first box of the row here. And let's say this is a 6304 bearing. We'll hit OK. There's my 6304 bearing. I highlight it. And when I right click, it will automatically, see there, automatically fill in all of those blanks. So let's say the back bearing, so we highlight this one, is 6204. Just because I want to do something odd, hit enter. There's my 6204, highlight it, right click. You can see it replaces that. And that'll do that also back here if I do any driven equipment. So if I'm in here, same thing. I highlight this one and then I'll fill in that. So that makes life much simpler if you're doing data collection. These three don't work. This last one where it says DFIG wind turbine, that one does function. You can see it's just a checkbox that will tell the software that it's a DFIG, which is a suprasynchronous machine, which means it runs greater than the synchronous speed. So we're going to go ahead and leave that there and open right now. So once we have this, what we want to do is make sure our settings are correct for what we want. And in this case, we are going to be at 100 millivolt per amp because I'm on the 20 amp setting on the CT. We're going to leave this as 1. And then we are going to save this data. It'll save as a JSON. So let's go ahead and click Save. And we are going to go into a new one. We're going to create a new machine. We're going to call this one Test Version 2.0. I'll use a dash instead of the point just for my own reasons. But I'm using Windows. Okay, so Test Version 2.0. So let's open up that. And we're going to call this the laptop motor. Okay, so there we are. I like to do one more thing. It is not necessary, but just because of things that I do when I do data collection, it's always a good habit. So I'm going to go ahead and call it that. Okay, it tells me I'm successful. Now here's some things I can do. If I wish to have a whole bunch of the exact same machine, I can create folders and then copy and paste that JSON into all of those folders, or even save it right from here into different folders and create a hierarchy for how many ever machines I want that are all basically identical. So that makes it much, much faster. The whole point here, including the bearing database function, is to make those improvements. And you can see you're keeping tabs on what you did. So if something goes awry, and say you need tech support, you call us and, we'll walk through, what you ran into and what it's telling you, and we can determine what might or might not have happened. We use this for debugging, so decided to keep it in there so that there's data as you're operating the system that you can see. So let's go ahead, and we are going to go straight into an analysis. So new analysis, now that I've saved some data, so I'm going to click on new analysis. See, it's basically doing a few things. It's going off of the nameplate I have. It's not going to ask for a new one, so I have to make sure my nameplate and all my settings were right. And you can see it's got some waveform showing up. This is my laptop, so it's not a motor. And we are going to go ahead and collect data. When I collect data, I'm going to pause, because it is a 2-minute data collection. So let's go ahead. When I hit collect data, this will freeze. It's going to ask where I want to save that data. You can see the folder where you want to save the data. You do have to have a JSON in that folder already. Or you can put it in later, but you do want it in there. So let's go ahead and save it. You can see that it is a WAV file. That is a sound file. We are taking data at 44.1 kilohertz at 24-bit, which means high resolution. This just happens to be the way it looks, but that's to show something's going on. So you can see the countdown is there. I'll bring us back as soon as the countdown is nearing 0. Okay, so you'll see this will run all the way down. This is going to stay there. It's going to ask for an OK. So I press OK. You can see it's running stuff in the background. So it is setting up all of this stuff here. Now, as you're going through and analyzing stuff, I myself do this as well. This is a nice reference to go back and scroll through. If I see something and I want to get some certain values, I can do that. Okay, and there it goes. It's now filled in the data. Now again, remember this isn't a real motor, so everything's going to look kind of funky. But in any case, here I go. I'm all set here. It's identified watts, but it hasn't pulled anything up yet. Now I can navigate around. I can do whatever I want. But let's go ahead before I show you the new features in here, and we will go ahead and auto-analyze. Now this is much, much faster. We have a well, it's an IP, but basically we have developed a methodology to immediately and very, very accurately detect speed. So let's go ahead and hit auto analyze. A pop-up box shows up, by the way, that tells me analyzing, please wait up to 2 minutes. It's on another screen right now. Although it's not going to take that long. As you can see, it's looking for, and you see this maxima detected near. It looks at the bin size and it says, okay, what's the highest peaks in that bin size for these frequencies in order to make sure that we're detecting everything. So it's looking for those max periods. It's also looking on unloaded machines how close everything is to the actual line frequency in order to determine if that's going to be a valid call or not. There is a color code in here. Black will be bearings, yellow is speed, and then various colors are for the stator and pole pass frequencies and eccentricities. When it's done, you're going to have everything on this littler part here, but I'll show you what we can do with that. Now, this is all the same resolution. As a matter of fact, when we cover some of the other features in here, you'll see even out to 22 kilohertz, we are at 0.008 hertz resolution. That's why we run for 120 seconds. Now, we do lop off the first 10 seconds because sometimes there's some settling in the current clamp, and we want to avoid that settling. And we found that settling can last several seconds. So just rounding it up to 10 usually works. Okay, so it thinks it sees certain things, which, yeah, you can see that these are lining up on different peaks. These are the bearings. There are labels on there. I can select this and pull that down to read them in more depth. You can see the speed is here. Pole pass frequency is in pretty close. That kind of thing. It went ahead and called it as a rotor bar anyways. Out here you can see my static and dynamic eccentricities, and then out here is the stator related issues, both stator electrical, which indicates degradation of the insulation system, and a couple other things. Winding stress will show up only if the certain peaks show up within a certain range, and they do in this case. So winding stress would refer to improperly set VFD, basically the nameplate information put in incorrectly or not being tuned. Could also relate to other conditions related to partial discharge, which is basically what we're seeing, stuff that affects the air gap of the machine. You can see the RPM here. So it's estimating that it's an unloaded machine. This current is way high, so it's going to tell us it's overloaded, that kind of thing. I can come in and zoom in on any of these in order to see stuff. This is the zoom. I highly recommend that you experiment with the different buttons. See, here we go. All the bearing information right there. Okay, now there's a direction I go for troubleshooting. We will cover that in the next section when we go through all this stuff. Okay, and then home brings me back. This steps us back or forward through what we are looking at, and so on. Okay, so there we are. Now, here's one of the new features. I can come in here, and if I right-click, I get a spectrum that I can expand to as large as I need, such as this, where I'm now at full page, in order to come in and take a look. I can zoom in certain areas. Okay. And if I come in and I have a particular interest in a peak, I can hold down Control, cover exactly where I want that peak, this can get a little exciting, and it will find my spot. So if I then right click, I can get rid of it. So let's go ahead and try that again. Well, it wants to go up there for some reason. Control left click. Okay, so something went a little buggy on me. I'll have to look into that. But it will normally do it correctly. So control left click. There we are. Right click. Control left click. Yeah, for some reason it's climbing up there. Could be a fluke. Hard to say. But in any case, so I'm in here. I can do all my zooming in and everything else. I can do that. I can also get the lines up from before, most of them, by clicking that button, and it'll pop up the pole pass frequency and other things, and you can see the designation. So these will all be bearings except for my pole pass frequency and my running speed. And this will not be included in the report. I can save it as a PNG image and include it in an additional page and so on. So that's part one. Let's take a look at the estimated watts losses. So if I come in here, I can zoom in, and you can see this is showing the measure on the side in kilowatts, and I can identify the different points, and you can see down here as I move along where my system is. That is the hertz and the losses. In this case, because that's in kilowatts, that would be 290 watts. However, when I had it analyzed, it is providing me all of the bearing information losses and all the other component losses, so that I'm here. Now, because I have the number of hours of operating and the cost per kilowatt in there, if I click on Analyze, it will go ahead and analyze the information necessary and give me a cost for the year on what the poor conditions, or basically most of this is showing up as friction, maybe some lubrication in this one because I see a 14 versus the mid to low digits elsewhere. I get that together. Now it's calling a really high pole pass frequency, although I can probably subtract that, and that's it. Now if I go back here, after I do that, I hit save as a PDF, it will generate a report on this machine. Okay, so we have all this stuff. Now if I want to come here, say it's a pump with 6 blades. I'm going to make sure I select pump. Click that part. You can see it's going through some analysis. It's going to pop up another screen that will allow me to take a look and see what it called, basically. And then back here, it's going to identify any conditions for that report. The other thing I can do in here, and if I wanted to, and I said, okay, and I put in, say 4-inch shiv at the motor, an 8-inch shiv at the pump, and we'll just call this 44-inch here for fun, and I say it's a belted application with that pump information, and I now analyze the driven. It's going to adjust the speed of the pump, and it's going to pop up some other conditions that I can look at associated with the fan and the shivs and so on. So once I have that, and then once it's done, it will tell me what all it sees. And I can adjust this in here and say, you know, that's a repeat. Just by going in and saying, okay. There we go. And then I can add any other notes. All that shows up in the report. Okay, so that's basically it from this standpoint. Oh, last thing. It had adjusted the speed for the pump based upon that. So any speeds related to this were based upon half speed. Now in the harmonic section, if I click on that, it will pop up first a screen that will show me a spectra excuse me, out to 22 kilohertz. And I can look for super harmonics in here. I can also click on this and it's going to pop up another window. That's going to be my straight current. That I could zoom in on if I needed to. Okay, and then I can open up the harmonic analysis finally. It's going to give me two things because the harmonic report is separate. And you can see it's looking at what the frequencies and the amplitudes are for the different harmonics. Okay, there's my harmonic. There's an area I can type stuff in if I want to, because this goes out to almost the 400th at 60 hertz. And there we go. Now I can save these, anything where I see the save, I can save that figure as a PNG. So let's go ahead and we'll reset. You can see that, and then it gives a percentage supra harmonics, and then it also gives a value for even harmonics. Okie doke. Now, next function is if we have this all set and we're going to collect new data, I don't have to start from scratch. As soon as it starts analyzing, it's going to replace everything. I can open a motor and select it. And that motor nameplate will update in here. And then I can perform the new analysis. The other thing I can do is for collecting data is basically make sure I have that nameplate data open and everything's checked, and go to data collection, which pops this up. Continuous monitoring is not selected. This pre-anomaly capture is not something that can be selected yet. I mean, you can select them, and it's not going to do anything. Before we come out with the separate continuous monitoring module, this will allow you to take, so in version 2.1, this is going to allow you to set your laptop or PC, the system, onto something, select continuous monitoring, and it will have a lag where it's continuously collecting data. And if some event occurs, it will take a snapshot of that data at 120 seconds, so you can analyze what happened when something fails or shuts down or whatever else is necessary. But here, if I say every 5 minutes, and I come down and I say start, it's going to want to save into a folder. So we're going to save into here. Oh, sorry, just says select folder. That's right, because it's going to timestamp it. Select folder, select the nameplate, and then just leave it alone. And I'm going to go ahead and take a quick break, and I'll come back and I'll show you. Okay, just for time, I'm going to go ahead and stop it. But you can see it says collected data. The other one is audio. That's the one we collected there. This was the one that we set up for basically testing every 5 minutes. I'm going to go ahead and click on stop, and it's going to stop doing that and then close. If I clicked on stop and it was in the middle of collecting data, it'll just freeze and it'll finish collecting the data, and then it'll open up and allow us to close. So, if I come in now and let's say I wanted to see that particular data set, the collected data, I can come in here, open analysis. See, it cleaned out almost everything. It says collected data, open. And then the nameplate JSON. And it's going to go ahead and populate based upon the data we've entered. And as you can see, there it goes. Now, I was asked about something, so we're going to test something as well, especially because the data collection thing, if I set it for every 5 minutes and I walk away, it's going to keep collecting data every 5 minutes, no matter what. So one of the things I'd meant to do was do that with a memory stick and see if it collects it properly without too much trouble. Now I've opened it. Now I have to run the auto analysis and everything else in order to get it to troubleshoot that collected data. That's it. That is the fun with the EMPOWER system. Again, we're going to do a couple more sessions here. This is a quick overview of the software. We are going to, in part 2, cover some basics of understanding the analytics for users. And then in part 3, we're going to have a session on setting it up for wind data collection. And thank you very much.